Hey YouTube, this is gonna be the third video for us studying gravitation, and I kind of left gravitation last night at the end of part two, so I'm gonna continue from this part here where we were discussing the new mass of the globe. Whenever we have an object below the surface of Earth, there's two parts of the Earth pulling it, right? So let's say if the mass is over here, this part is going to pull it up and this part is going to pull it down. So the resultant force is this force minus this force. But in this situation, we can always assume that the fraction of the earth that is actually pulling the object can be can be shown as just a sphere of the radius r from the center. So that's what we did here. And now whenever we use the formula gm upon g equals to capital Gm upon r square, wherever we use the radius of the earth, we're going to use this new radius. And so now I'm going to discuss the formulas linking this entire topic, gravitational fields. So the first formula we studied was G equals to F upon M, which is the defining formula. I'm going to write it down again. So yeah, first one was G equals to F upon M. Hold on. Yeah, where the M is the mass of the object, not Earth. And then we can go in and replace the F with the formula capital M R square. And we're going to know that the smaller m gets cut by the, see, there's going to be a capital M over here and an M over here. So this M will cut the smaller m, and we're just going to be left with the mass of the earth. So then we reach the formula G equals to capital G M upon R squared, like this. And remember that this R squared is the distance from the center. This is not the radius of the planet. The radius of the planet is always denoted by a capital R. Moving on, we can then replace the m with density multiplied by volume, and then we can replace the volume by 4 upon 3 pi r cube. Over here, the r is going to be the radius of the planet. So we go ahead and we get the formula G dot 4 upon 3 dot pi dot r cube into density upon r square, like this. I hope you guys can see. Yeah, this one. See how over here we have the capital R and this is the small r. These are different and these are going to stay different. This formula is unconditionally true for any point in a field, whether it be above or below the field. Now we're just going to talk about for objects below the field. We just came to the conclusion that we can say that the fraction of the earth that's pulling them down is just a small sphere in the center with this radius r. So in this formula, the radius of the new planet is going to be the same as the distance from the center to the object. Yes, mama. Mama, don't video बनने होती है यार.